Hello, everyone. This is Saeed and Mubarak, and I'm very pleased to join you virtually in this workshop. And I hope you've been enjoying the program and you will be enjoying, hopefully, the rest of it. Well, intelligent completions is a subject that's very dear to my heart. And I would like to share with you some of the experiences that I had with them. And the title says it all. Intelligent completions, are they advanced or are they complex? I usually start with a few tips that I would like to share with you at the beginning of this presentation. When it comes to technology, same ingredients do not yield similar results, and definitely these completions have different sizes, different properties, and the environment that they will be deployed at are different as well. And there isn't one size fits all, and they exist in different types, different methodology, and different applications. Well, one would definitely do the investment, but they need to make sure that it fits for a purpose. So you need to know exactly their capabilities and their limitations to make sure they're really fit for purpose, and they have to be looked at as a servant to meet and achieve your short-term and long-term objectives. And definitely that takes more of a holistic view on the whole thing and on the strategy and the deployment and knowing the reservoir, the surface and subsurface infrastructure. And these are the things that we will be discussing in this few minutes that's in the slides. But prior to that, I think everyone knows that things go through evolution. It's not really societies only. I mean, where do you see societies from hunting to agriculture to industrial, and now we talk about knowledge, but everything goes through evolution. You look here at Apple, for instance, it started from the top left corner there from a wooden box to the bottom there, where everybody has his own or her own almost PC on their bombs, and you could communicate, you could photograph, and you could. So that's the evolution part of it. But the evolution is not really limited to a certain technology or a certain industry. You go and look at the rigs from left to right, and even wells and completions. Looking at the completions, starting from a vertical well and Paco as reported, and then definitely there were other older wells and more recent wells, but this is what's been reported, 1848. Then horizontal wells after almost a decade, then multilateral wells. Then in 1997, the first advanced completion or smart completion or intelligent well was deployed by a Norwegian field. Now, then in 2000 and the 2000, early 2000, many of the deployments, started. And as far as I know, the deployments of advanced completions or ICVs, downhole valves, is about 2000 as of today. There are more of pilot or trial test on downhole valves with multi-phase flow meters that are continuous on subsurface in 2006, and the extended reach completion, which is called using Meador, which is a famous completion. That's more pretty advanced one. With the first deployment in 2013, and these are more of stations, modules that are installed either in laterals or in segments. Now, let me brief you at least, or give you more of a quick video that I developed with help of the media to demonstrate where these wells are located and what are they from an intelligent fields and what they're used for. So take a minute.
A smart well is just like a root of a tree. If the tree has more roots, it has more chances to get more water. So we go and create our own roots, and these are the multilateral wells that goes and branches 2 kilometers below the ground. And we give every branch a sensing capability plus a control capability, so we know where the fluids are coming and what kind of fluid from each branch. When we connect these smart wells together using fiber optics, we then have access to vast amount of real-time data to make faster and smarter decisions and maximize oil and gas recovery. These interconnected smart wells are known as intelligent fields.
Well, people have different perceptions and definition of what a smart field is or a smart well is, and even a smart completion or intelligent fields. But as you see here, for smart wells or the wells equipped with ICVs, they're mostly multilateral wells, and they have to be really fit for purpose, just like we indicated in the tips at the beginning. Now, what comes up with these smart completions, if I take you to a journey to the field, at least to see what's really required at the surface, and if you look here over it's a wellhead definitely, and there is a plant and an IT infrastructure to a desktop, and this is where the communication is supposed to go from the well and the data that flows from the well through this basically process from plant to IT to desktop. But at the surface, you would look over the picture over there, you would see shelters over there, and they're different and many equipment that are needed to operate and actuate these downhole valves. Let's take a closer look over there. If we have a multilateral well, which is the top basically structure there, I mean the picture, you would need to have a surface hydraulic system that can be electrical or hydraulic. You would need a multi-phase flow meter, definitely an RTU, a SCADA system or a similar one, ICVs that are subsurface, and PDHMS, and these are permanent downhole gauges to make sure that you at least monitoring pressure and temperature either across the valves and maybe above the protection packer. And all these informations or equipment basically are providing you with either capabilities or data to give you the capability to control or maybe monitor and optimize, just like the video stated. But let me share with you a real example, so at least you could feel what they're used for. And over here, it's a case study. This is a true story. And if you look at it, it's a multilateral well, A, B, and C. These are the laterals. The black circle is closed. I mean, if it's colored, then it's closed valve. If it's not colored, then it's open. Over here, A is half open, B and C are closed. And if you look at the right side, you see a blue column there, which is water. And if you've closed A, we closed C, and we opened B, it was producing a green column, and that's the oil, just to make it simple over there. Closed A, closed B, open C, 50% oil and water. At a different choke setting, this was producing only oil, and we know that lateral C was intersecting a fracture. If you introduce a higher drawdown, you invite basically water to the system. And over there, we've known the objective, we know the capabilities of these advanced, valves, if you want to call them advanced. And we decided basically after iterations and analysis to make the final setting to close A, B partially open, and C partially open, restricted. And it was producing 6 MBD for a long while. This optimization that took about 2 weeks was done in 2005-6, and the well is still producing, definitely at different rates, and there was multiple iterations of this optimization. What you see here, or you've seen in 1 minute, took us 2 weeks to digest the data, to understand basically what's going on, knowing the knowledge about the reservoir, the facilities. So it requires knowledge, experience, modeling, and intuitions as well. But definitely it needs experience, people who are aware of what the reservoir is and the completion is and their capabilities, limitations, the multi-phase flow meter and how they operate. And they know the target and they know the objectives of these wells. Let me give you another example just to see appreciate also the what might be done with these downhole valves in certain other cases. And this is again a trilateral well. Mother-bore is MB. This is lateral 1 or 0. Lateral 1 and 2. They usually name them as lateral 0, 1, 2. Deeper to deeper is lateral 0. Anyway, the well was producing at the beginning fully open, all of them, and the estimated rate was from the mother-bore 2.5, lateral 1, 2, lateral 2 is 8. So 8 was dominating the flow based on the estimated rate from every lateral. The objective from this maximum reservoir contact, which is 5 kilometers of exposure to the reservoir, and each lateral is more than 1 kilometer, is to make the contribution of these laterals equal. And this is exactly what happened after optimizing the choke settings of these valves. Now, a third example, and this is another actual example. And if you look at the table over there, initial ICV settings were fully open, 10, 10, and 10. And after iterations and optimizations, the team decided to put lateral 0 to 10, lateral 1 to 5, lateral 2 to 4. And the initial rate was 8.6, and bottom hole flowing pressure was 1927. Just imagine that we restricted the laterals 1 and 2, and the rate increased. Not only this, even the bottom hole flowing pressure increased. And after analysis, that was an indication of more of communication between the laterals. So there was a strong lateral of them that was more of communicating the other ones and making basically the total rate at the surface less. And that's again, is it preventable? Maybe not. Is it within the current system? But people have thought about ideas and came up with innovation, more of a one-way valve, which is more of a check valve, just to make sure that to prevent the corrosive flow, just in case it happens without you know. Now, what happens if you have all these infrastructure serving you, be it the surface infrastructure, the surface hydraulic system, multi-phase flow meter, and all the capabilities and the knowledge. And over here, more of it's a circle on that shows the time cycle. And we usually go and use the information, do analysis and decision and action. But definitely, when you have all of these capabilities and they're really, really reliable, then one would be able to close this circle or cycle at a shorter time. So what took us 2 weeks, if we don't have, let's say, a multi-phase flow meter or the surface hydraulic system, then it might take a little bit longer to do the analysis and make an action. So you have to have the full set to make sure that you close this cycle at a shorter time. Now, let's go to the hidden word, which is basically that has a little bit of complexity in the system. This is more of the picture on the left. It demonstrates a trilateral, which is basically demonstrated in the right by itself. But that's a multilateral well. But within the structure, I mean, if you have a single vertical well and you have just one valve, that's an easy thing. And this is what I call the hidden word. Can be simple. It's just like a valve. And let's assume that you have two reservoirs with known properties, you know the pressure and fluid dynamics delta P. Then all you do is basically, and you have, let's say, BDHMS, which is a pressure gauge above and below the valve. You could estimate the rate from these that flows through the tubing. Now, but this story can be a little bit complex, especially when you are dealing with laterals, and every lateral, be it belongs to a reservoir A, B, and C, be it belongs to different layers in the same reservoir. That's a bit complex, and it adds more variables to basically digest and to optimize and to make sure that at least your estimate and your analysis is right. Now, what adds to this is basically the multiple chokes that every valve has, which is 10, it could be 6, 8, and it could be 0 to 100%. That's a bit complex, and the industry hasn't come up with a solution that we call an optimizer. That's just, they brought the technology and it has the capabilities, but definitely a user would love to have more of a full package that has the subsurface and surface and optimizer or a modular for it. That's handy, user-friendly, and engineers can use it, maybe adjust it according to their fields and systems. Now, for the requirement for full utilization of these systems are technologies, the business environment, processes, and people. And if you look at it in details, it's surface technologies, subsurface technologies, simulation or modeling tools, integrated systems, optimization procedures, and definitely experts. Now, looking at it from the 4 categories: enabling technologies, the smart completion, the multi-phase flow meter, and others. Business environment, how you communicate with the counterparts, production engineering, producing, and reservoir management, and all of these, and how they're structured, the roles and responsibilities, the business models, optimization procedures, and definitely people. They're the engineers, the operators, and everyone, management and leaders. Looking at the spheres over here, the bigger the sphere, the higher the investment. So technologies are really, really expensive. And definitely, if they're used right, then they produce value. If they're not used, then they're basically, I wouldn't say they're an investment. It could be a pre-investment that would be used in the future, but definitely they're expensive. People are your engineers, whether you have technologies or not, but definitely if you have technologies or new systems, you would need to train them, and this is basically where the cost is there. But looking at it from different perspective and looking at the x-axis, which is where the value comes from, it comes from people. People are the ones who are inventing technologies. They're the ones using technologies and coming up with innovation and how to use them, optimize them, and maybe adjust them. And definitely they are the ones who make up the environment and coming up with optimization processes. And they're the ones looking at the thing from the holistic view on the thing. They look at it from the reservoir, the strategy, the business plan, and the targets, the capabilities of the technologies, and other things as well. Now, nowadays you will hear a lot about not only wells producing only oil. That wells now produce, and that's basically what everybody speaks about. And you might be hearing many of the subjects that are covered within the workshop here about data and where data is used, be it data mining and how it's communicated. You will hear about big data and artificial intelligence and machine learning. And definitely that's a territory, another territory that comes up with advanced completions or wells that have basically components that makes us call them smart wells or smart or intelligent wells. Now, but reality is wells age, and definitely fields mature, technologies get obsolete, and the advancement in these technologies are really, really quick. And definitely the environment constraints and concerns are increasing, and everybody speaks about them, especially in the last decade. Now, what comes up with aging wells, production losses. So you need to account for them, and you need to make sure that at least you don't want, let's say, higher production of water. Maturing fields, resource intensive, including the aging wells, extensive surveillance, then technologies. They come up with they need to come up with the intensive maintenance program just to make sure they're reliable. and definitely they're higher investment. With the environment, everybody speaks about the environment today. It's emissions, energy transition, and other issues. So these are subjects that are realities, and realities basically that everybody needs to be aware of, and they need to account for. Now, let's see what comes up with technology other than the subjects and topics that we mentioned. And this is more of the last clip, which is a short one, but that's the entertainment part of in my presentation.
Whoa, that's not good.
Oh, I don't need this. I'm already late.
Somebody will come. Anybody out there?
Do you have a phone?
No. Sorry. Somebody! Hello? There are 2 people stuck on an escalator and we need help. Now, would somebody please do something? Help! I don't believe this. You gotta be kidding me.
I'm gonna cry.
No. Well, there's not enough left to do, is it?
Hello? Hey, don't worry about it. I'll fix it in a second.
He said he could fix it. All right. All right. That's more like it. He says he can fix it.
Well, the message is clear, so I don't have to really elaborate. But over here, it's more of a cartoon that shows the 6 blind men touching an elephant, and they're blind. They don't know what the elephant is, but every place they touch, every one of them touches a place, and they call it something. In reality, if we want to see the elephant, we don't have to zoom in, and sometimes focusing on something and zooming in might mislead you, or mislead an individual to see the whole picture. And especially with these completions and these systems and technologies, we might look at, be better to look at it from a zoom out, a different basically place where you see the whole thing. And when it comes to advanced completions and technologies, it has to be put in more of an holistic approach where you could see where it fits, where it can bring value, and where it might be introducing complexities or issues. So if you want to see the elephant, we need to go to the place where the kid is basically looking at it and laughing at the blind men, describing what they're touching. Thank you very much, and look forward to the Q&A and the rest of the panel discussion. Thank you.